guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now that I went over the example with pentane and its constitutional isomers, I'm now going to go over the nitty-gritty of the substituent rules. And so the first rule is we always number the parent chain to give the smallest possible number. So as an example again, let's say we have this molecule, a 4-carbon chain, and then CH3. This is the example that I gave before with the pentane. So remember that I said it's 1, 2, 3, 4, and not 1, 2, 3, 4. Because in this case, we can call this 2-methylbutane, whereas this would be 3-methylbutane. So you always want to number the parent chain to give the smallest possible number. Second rule, name the substituents alphabetically. So let me show you an example of this. So if I have 1, 2, 3, 4, 5, 6, 7 carbons, that's the parent chain. Now I'm going to stick a methyl group right here, and let me also put an ethyl group right here. So in this case, we have a 2-carbon substituent. It has 5 hydrogens instead of 6, so this is called an ethyl group. And this is a methyl. So when I basically name this compound, I'm going to put the ethyl before the methyl due to the fact that E comes before M in the alphabet. So when I number the parent chain, which is the guy right here, which is 7 carbons, and so we already know that the parent chain makes this molecule end in heptane. And I'm going to number it so that the ethyl comes before the methyl. So how would I do that? I would go 1, 2, 3, 4, 5, 6, 7 instead of going 1, 2, 3, 4, 5, 6, 7. So in this case, this compound would be called 3-ethyl 5-methyl heptane, and not 5-ethyl 3-methylheptane, which is the alternative if I started numbering it from the other side. So we always want the lower number on the guy that's going to come first based on the alphabet. So rule number 3, prefixes that indicates the number of substituents is not included in the alphabetizing. So what I mean by that is, as an example, we have 1, 2, 3, 4, 5, 6 carbons. I'm going to put 2 methyl groups right here. And I'm also going to put an ethyl group right here. So this guy is clearly the parent chain, right? So the parent chain has 6 carbons, so it's going to be hexane. But the fact that the prefixes indicating the number of substituents are not included in the alphabetizing makes me think that the ethyl is going to come before the dimethyl, because the di that comes before the dimethyl, since we have 2 methyl groups on this central carbon, the D comes before the ethyl group's E, but it's not included in the alphabetizing, so ethyl is still going to come first. So when I number these guys, I'm going to go 1, 2, 3, 4, 5, 6, but I'm going to name the ethyl first. So it's going to be 4-ethyl 2,2-dimethyl hexane. So now let me explain to you why this is not numbered the other way around. If I numbered it starting from this carbon being 1, 2, 3, 4, 5, 6, then this would be 3-ethyl 5,5-dimethyl hexane. And basically, we want to have the smallest possible total number, right? In this case, we have 4 plus 2 plus 2 is 8. But in this case, we have 3 plus 5 plus 5, which gives us 13. Since we want the lowest possible number, this is the correct way of numbering the parent chain. But the ethyl still comes for the dimethyl because this guy, this prefix, is not included in the alphabetizing.